CCMT, very similar. I won't necessarily touch on every single item here. Positioning is obviously basically the same as a CCM. We don't want to mount that valve in an upside down fashion. And keep in mind here, the CCMT can be used either as the receiver bypass valve, or it could also be used as the high pressure valve, depending on the initial design. So this could fall into two different categories there. Troubleshooting from that standpoint, if we're dealing with one of these valves, again, not opening or closing, which is our most common troubleshooting point for the valves. A lot of the same things here that, again, I won't touch on those first three bullet points. That's exactly the same that we just talked about with the CCM. One of the things we do have to watch, though, with the CCMT, T standing for transcritical, because it can handle those higher pressures up to 2000 PSI, is that we have about a half a dozen different options or different sizes of the CCMT. So we have a 2, 4, and 8, and then we get up into this range that has a few options, with the smallest being a 16 and the largest being a 42. This range actually has a higher phase current as part of it as well. So the EKC 326A was only driving stepper valves that had 100 milliamp phase current. So if we've got one of these newer CCMTs and we want to tie that into a controller, they have a much higher phase current, 300 milliamps. We need to make sure we're tying it into a controller that could handle that phase current, because the EKC 326 could not. Pack controllers can, but whether it's the EKC or maybe even something else we're not talking about here, phase current on some of these newer, larger CCMTs is something that has to be taken into account, because not all controllers can handle that 300 milliamps.
Okay, so that's a good point. So you won't see this too much, because this is usually done by the manufacturer of the equipment. They're gonna pick the proper controller for it that has the proper phase current. And if you're going to replace a controller, most likely you won't have a 326 running a CCMT 16 or 42. So it's just to be aware that it does have a different phase current.
Yep. And I think maybe, and again, maybe a small percentage chance that we're ever going to play out this way. But if we had a system using the 326A, and maybe the receiver bypass valve went bad and it was a CCM, and just say they couldn't get it as quickly as they needed it, but we say, oh, we've got the CCMT that could be used in place of it. That's maybe a situation where we'd have to take a step back and say, well, we can get that CCMT out faster, but if it's being used with the 326, we can't do it because of this.
So that's a really good point there, because this could happen. Are the bodies the same? Can I put the valve from a CCM to a CCMT?
Nah, the design's different, and the pressure ratings are different on the two as well. So yeah, exactly. It wouldn't be a swap that you could do there.
So that's a good point, though. So if you can't get the CCM and it's a CCMT, you may need to upgrade the controller as well, which makes sense. Okay.
Yeah. Existing installations, you can see some of the ratings here. So the smaller CCMTs, we have that same 52 ohm rating that we're looking for to kind of give us the green light that the motors are okay. And then when we get into these larger CCMTs, that rating is only 29 ohms that we're looking for. So good to keep in mind that it's not just blindly 52 ohms across the board. We do have some models where it's a different resistance that we're shooting for at 29 to tell us that the motors are okay. And then similar troubleshooting techniques after we've kind of checked the motors through ohming them out, the power cycling, again, with the pump down being part of this to recalibrate the valves. And then we may need to use that same valve driver that we would use for the CCM. We can also use that with the CCMT to try to drive those valves in an open or closed position to recalibrate them and make sure they can move. There is a filter. I also have a point about this, not depicted anywhere, but these larger 16 through 42 models, there is a filter on those, which is good to keep in mind, an internal filter. So you can open the valve up and visually see and remove that filter if you need to. So that's something good to check as well. It could be blocked, could be causing some high pressure issues if that filter's jammed up, and we can check that by opening the valve up.
Yeah, and that's important, because this is we've seen it time and time again where there's a lot of dirt in the system. I know we're doing better jobs with cleaning, but if you're not on some, especially stainless steel, a lot of the welders they don't need to have a lot of clean systems when they're welding. and in, and this could be a potential issue where there's dirt in the system.
Yep.
And